All right, so let's get started with some housekeeping, as I generally do that at first, but then we're going to dive straight into doing work in the textbook. But if you haven't created an account for the textbook, that's okay. It shouldn't. I just gave my laptop a static shock. It's wonderful. All right, so isn't it amazing how robust computers are these days? All right, so first and foremost, you may have noticed that a bunch of you have lab on Monday, or are scheduled to have labs on Monday, I should say, right? Is there lab Monday? No, there is not. How does this work? Well, the way it typically works, the way Temple's academic calendar works is that the second Monday of the semester, be it in fall or in the spring, is always off. That's all the way it is every single semester. And then if you notice, the way the course calendar works every single semester is that the last week, the week finals start is that they have Monday is a normal lecture day, and then Tuesday's a study day. Sometimes Wednesday is as well, but it's always basically there's this random Monday at the very end of the semester that's like the last day of classes. That's what happens there. Essentially, that next week's Monday gets bumped all the way to the end of the semester. What does this mean for you? This means that essentially you should look at this class. The week essentially starts on Tuesday, right? The idea here is that this semester, at the very least, I'm going to give you your lecture on Tuesday, your lecture on Thursday, and then the labs are on Friday and Monday respectively, right? That makes sense? So Lab 2 will be covered in essentially the third week of classes. Make sense? That makes sense to everybody? So your Lab 2 will be, so let's go ahead and just pop up the calendar. Okay, clear all. Calendar. So you can't see this over face on let me just move, whoops, that was the wrong thing. Let me grab me for a second. All right, sorry, no, I'm just trying to make this for the recording easy to see. All right, so over here, this Monday is off. This Monday over here, the 27th, that will be your Lab 2 if you've got Monday labs. If you've got a Friday lab, this entire point is moot. It's your labs occur on Friday. So why am I bringing this up? Lab 2 will be our first quiz. Seriously, do not panic about this. It is made to be super simple. I told the TAs to review what is going to be on it before they give the quiz out, and that's the way it's going to work. This is just simply me trying to incentivize and motivate you to actually show up to the lab that you're registered for. By which I mean and when I say don't panic, I mean I'm giving you half of the points on the quiz for writing your name on the quiz. Okay, that is the level of don't panic I am talking about. The quizzes are not meant to be difficult. They are meant to be review questions. They're meant to make sure that, especially this first one, meant to kind of make sure that you're showing up to your labs and making sure that you are doing the work you're supposed to do. Okay? So let me move myself back to where I normally am while recording. All right, so I will upload the recordings. They'll be over here in lecture videos. And again, in this first lab, you are, and if you missed it on Monday, again, try to catch one of the labs on Friday or try to complete the lab yourself. Once you finish the lab, you realize, wow, this was actually pretty easy to do myself. So we'll focus on that. And again, the instructions for doing the lab, if you need to do it yourself, can be found here in the installing Python and then following the instructions in the lab. It is very much to follow the instructions, make sure Python is set up on your machine to use it. Okay, today is making sure we're set up with the other portion of what you need to do, which is your textbook. So if you haven't done so yet, what you need to do is you need to get a copy of Foundations of Python Programming, which you can do right now by going to Canvas and clicking on this link, or going directly to runestone.academy. Yeah, just runestone.academy, okay? And then signing up for the textbook. To sign up for the textbook, you use Spring 2025 Rosen. That is your textbook. It is free, so you should definitely get it. because we're going to be working out the textbook today. So I will give everybody a minute or two to make sure that you're there, or to pull out your a laptop if you don't have one, or a phone, or because you can do this one totally on your phone. Also, just as I mentioned at the end of last lecture, if you have a laptop and you find that your battery needs some charging, the seats all have chargers in them. It's this black bar right over here that's underneath the seats. And those basically, and they're in between the seats, kind of where the armrests are. There's every so often there's a charger in between them, so there's plenty of chargers where yeah.
What's the course name again?
The course name? Excellent. Sorry, give me 1 second. The course name for the textbook. It is Spring 2025 Rosen. I always use the same code, except I just changed. I always use semester, fall or spring, and then the year, and then Rosen for this to keep it simple. So you just need to make an account on this. And again, to make my life easier, I request that you use your TU email, meaning TU letter, then the 5 numbers that you've been randomly assigned. This just makes my job easier because I will show you my script later on in the semester that takes 2 CSV files, 2 basically grade books, and combines them together into 1 grade book, so that I don't have to go through and manually copy your grades over. Because I don't trust Canvas enough for the integration that Runestone has to necessarily work with it. And I try not to do that. Otherwise, if you don't do that, if you use the same first name and last name that you did on Canvas, that should work. I try to be pretty thorough about this. And finally, the last thing before, while you're getting this set up, there's a Discord invite here. Please come and hang out on Discord. I'm going to be holding a Icebreaker gaming session on Discord at 7 p.m. on Saturday. You do not need to show up. It's just simply something fun to do in the first week. We'll be doing some stupid trivia games like what you can find on Jackbox Games, because those generally scale to extremely large numbers of people. So if you want to show up, on Discord, it will be done on the in the video, in the streaming channels on Discord. The ones labeled distraction. So voice channels. That's what I'm trying to go. So all you need to be is logged in on Discord, and you'll be able to find them. And ask around if you can't. That's fine, because you may not have used Discord and be completely unfamiliar with that. All right. So once you're logged into your textbook, you'll land on a page like this, right? Once you're logged into your textbook, you'll land on a page like this. To get to the actual textbook itself, you click on Textbooks, Foundations of Python Programming, and then this will bring you to the textbook, which, again, I want you to go through Chapter 1 for the first week, Chapter 2 for the second week. It's fairly consistent for the first few weeks before I start jumping around the textbook, because I find the way I find to do things. But the textbook will end up like this, right? So you're going to want to go from here, click on this link to head to here. Once you're on this page, I need you to scroll all the way down to find this, a preview of the end goal. Alternatively, because I always love having multiple ways to do something, if you go to the Module 1 overview page, and you can do this basically every single class, let's go ahead. I will go ahead and do this now. Edit. I will go ahead and hit link option, and I will just simply change, and all I have to do is change the URL in here now, because this is why I do it this way. Spring. Done. save. And so now if you go to Module 1 Overview, you can just click directly on this, and it will bring you to the appropriate, page that I want. So you can either just log in directly through your textbook, you can go to the Module 1 Overview and click on it, and it'll bring you here. Okay, everybody okay with this, or is anybody stuck for some reason? All right, so I'm going to assume everybody's doing fine. All right, so today's lecture is to kind of show you what we can do with computer programming and kind of give you a glimpse of where you should be ending the semester on. We can do and I like what it says. It can do from understanding human speech to image processing to computer-generated animation. You can do almost anything with code. But like anything else, you have to practice. You have to do the basics first. And it makes that music comparison I made during our first lecture, saying that you wouldn't be able to sit down at a piano and expect to play a very complicated piano piece the very first time. You have to work up to that. This should give you an idea of what we can work up to, right? Because with piano, at least, we have piano pieces, piano sonatas that we can look at and say that's what we aspire to, right? It's on the other hand, with computer programming, it can be very tough to see, oh, what's a difficult task versus an easy task. And it points out again that one of the difficulties here is unlike the other courses you may have taken, because you've read books before, so English isn't too foreign, even if you have to do material that you're not too familiar with, right? You've had to do math before, so calculus and pre-calc, that's at least like, even though that's new stuff, it's not necessarily like learning a foreign language. And learning a foreign language, at least you're going into that knowing doing something that humans have done since humans have existed, learning other languages. You know, that's something that we understand pretty well. On the other hand, computers and computer science is a fairly new discipline as opposed to the other stuff. And the tools we have are, rooted in some legacy stuff. The most important thing, and I alluded to this earlier in the previous lecture, the most annoying thing is that it often feels like you're having to fight against the computer sometimes, because the computer will do exactly what it's told to do, which is not necessarily what you meant. Often, you should just treat your computer as an evil genie, or if you've played Dungeons & Dragons, as the DM who's trying to utterly corrupt and pervert your wish spell that you're trying to cast, because that's exactly what's going to happen here. All right, the idea here is that you will find that little typos can really mess you up. I pointed this out. If you happen to go through the trouble of reading my teaching statement, you may have not found the typos I left in there on purpose that human eyes just simply float over because of just the flaws in the ways our eyes work. All right, so long story short, don't get discouraged, because it's very easy to get discouraged and beat yourself up about understanding something completely new and foreign. You're not stupid if you can't, if you have trouble with this. You're just human like the rest of us. All right, so we're going to look at image processing today and kind of look at an example of a program. So this is a Python program. It's a fairly hefty one for an intro class, to be honest. And you may or may not be able to figure out what it's doing when you look at it, but honestly, that's not the goal. The goal is to kind of dive into it and see that it's not necessarily too foreign of a thing. So I'm going to hit save and run, and it will run. While it runs, I'll explain. So here it goes, and we see it's running, right? And it's doing something with an image. It's taking a bell from Luther College, and it's doing something with the image. So let's go ahead and talk about it. So the program is broken down into lines of code. The first line, generally in a lot of programs, although we won't need them for a while, are imports, saying, hey, we have all these cool programs that are already written by other programmers, and we can use them. They're called libraries. And this one, since it's an image processing program, it's importing the image library. A lot of times you won't have to import things. The only things we'll really be importing in this class are Turtle, which is fairly easy to do, and random, which is used for random number generation. Most of the time we don't need, but for this one we don't really need to import much of anything. Next is def, process 11, and it looks weird. You'll learn about these, which are called functions later on in the semester, but programming languages are languages, and they're languages you can modify. This over here, this statement says basically, I am defining a new verb in the language called process 11. It's not a very awesomely named verb in the language, right? Process 11 is very ambiguous as to what it does, but I can call it whatever I want. Here we just call it process 11. And this is an argument, which is called an image, and then you've got a colon. One thing that if you've done other programming languages, which again, I don't expect a lot of you have, but again, also a lot of you have done, a lot of you haven't. One thing that you should know about Python is that Python cares about white space. That's how it figures out what is inside a function. So because everything is indented inside of process 11, it knows, oh, all of this stuff, this is inside process 11 because it's indented inside. Everybody see how there's a bunch of white space leading up in front of everything? White space being this space that I'm moving around in my cursor. This is outside of it because there is no white space in front of it. We'll learn more about that in detail later. Again, I'm not expecting you to understand any of this right now. I'm just kind of giving you kind of an overview of this. Now this stuff over here that's highlighted in green, these are what we call comments. This is not code. What a comment is basically a bit of the program that is meant for the human to read. Computers will ignore anything in the comments. Like this over here, it sees this. He sees the hash mark, the pound symbol, the number sign, whatever you want to call it. It sees that and it says, "Aha, this is something to ignore. It's for humans." And we use this to comment on the code and explain what's going on. So over here it says, get the width and height of an image. Width and height. Images have a certain size, height and width, right? How big, how tall it is, and how wide it is, right? And then we have over here, which is going to be, and this over here will be the focus of essentially the first 6 weeks of our class, something called for loops. We don't start tackling them until week 3. So you've got a bit of a reprieve, but we will start tackling them sooner rather than later. What this effectively says, for every row in the height and every column in the width. So basically it's going through and getting every possible combination of row and height and getting something called, and then doing this line. P is equal to an image dot get pixel column row. So get the pixel at that row and column. So first off, what the heck is a pixel? Anyone? Yes. Oh no, I thought I saw your hand. No. Yes.
Just little squares that make up your monitor.
Exactly. That's honestly that's the best explanation I could give. It's those little tiny squares that make up your monitor. It is short for a picture element. It is basically the smallest unit of a picture, the smallest unit of an image. And it gets harder and harder to do this every single year. So if you get really, really, really close to your computer, really, really close, you can see that everything on your computer screen is made up of tiny little squares. Apple, of course, has done an amazing job of upping the game and making those pixels really super small. So you have to get really, really absurdly close to the screen to see the size of that. Typically, a TV, your standard TV, not your 4K, but your HD TV, when they say it's a 1080p screen, that means there's 1080 pixels vertically. Yes, vertically, as opposed to wide. 1920 by 1080. So 1080 being the height of it, and that's how many pixels are in there. And then, so that's what that refers to. And that's plenty of pixels. That's a lot, believe it or not. So let's go to Wikipedia for a sec. Wikipedia is actually pretty great at some things. Terrible at some things, great at other things. But for a lot of computer science stuff, for some reason, it seems to be really good. So for instance, over here, this is a picture over here, and it zoomed in. We can see, and it goes ahead and zooms in for us, and we can kind of see how this image, this curved line, is made up of pixels. And what it does is it tricks your eyes into believing it's actually made up of a curved line rather than a bunch of jagged squares. Those pixels are further split up into, and this is going a bit further than you need to know at the moment, but those pixels are further split up into what are called subpixels. Each of those tiny squares is in fact made up of 3 lights, one red, one green, and one blue. And those lights are turned on separate intensities to trick your eyes into believe it's seeing some color. So, and that is how that works. It basically just simply is every square you see is shining some amount of red, green, and blue in some combination. We'll get into how weird color can be in a bit, but but it's made up of those 3 values: red, green, and blue. And then from there, we should be able to make any kind of color we need to. Yep. So enough on that. What we're going to do, so now we go back over here. So here it says image.getPixel. So from the image, get a pixel at that row and column, right? Kind of like a matrix. This equal sign over here, as we'll discuss, is a symbol that doesn't necessarily mean equality, right? It's not setting 2 things on 2 sides of a scale and saying, hey, these things balance out. What it is that it's more of an arrow. It's more saying something along the lines of this, that we are taking this thing and storing it in a variable. Okay, it's an assignment statement, as we like to put it. Only the only reason we don't draw an arrow is that this looks like if it's an arrow, it might look like less than negative, right, for the computer, so that confuses the computer. And I can't do equal signs because it's like can be, p is less than or equal to. No. So some programming languages used to use this for the assignment statement, which I lovingly call the walrus operator because it looks like 2 eyes and tusk on its side, like a walrus. And in fact, some programming languages like Google's Go programming language still do use this in certain circumstances. So just simply it uses that equality sign. But simply put, if there's one thing to remember in this class, it is the thing on the right gets stored in the thing on the left. So we have a pixel now, P. This gets the red, the green, and the blue that I was talking about. Specifically, it's getting a number from them. It's getting an intensity from them. Basically, it's saying, hey, that you've got a red light, a green light, and a blue light. How much is that light shining for each the red, green, and blue? If all 3 of them are on at their maximum value, then I'm going to get a white light. If all 3 of them are off at their minimum value, their smallest value, at 0, if they're not on, if we don't have any light, what color is that? That's black, right? So the values of colors, for reasons that we will discuss later, are given a value between 0 and 255. That's how much there's in a byte. I'll get into that, why that is later. Just accept it as on face value for right now. And what this statement over here says is that if we add those 3 values together and divide by 3, in other words, we take the average of that, if that's greater than 255 divided by 2, remember 255 is that maximum value, so if it's greater than half the maximum value, I'm going to say I've got a new red, a new green, and a new blue, and it's going to be at those highest values possible. Otherwise, I'm going to turn them to the lowest values. So basically what this is saying over here is that if on average those lights are more than halfway on, turn them all the way on. If they're not on average more than half the way on, turn them off. So, and then what we do is we say we're going to make a new pixel from those new values and replace the old pixel. And then the rest of this code, which is not really too important, this code isn't too important over here, which just simply is hey, let's load the image up, let's set the image up and draw it, and then we're going to run this process on it. Now, and we can see the code that we're running in action here. And what it's doing is that it's going pixel by pixel. And what it's doing is saying, it's looking at the pixel and saying, hey, if it's on average a bright color, make it white. And on average, if it's a dark color otherwise, turn it off, make it a black color, right? So it's converting this into literally black and white, right? And going back over here for a second, I mentioned that over here what we're doing is that we're saying, hey, def process 11. Basically, as I said, we're making a new verb in the language. So we just make a new verb, we describe what that verb means, we give it a definition, and then we proceed to use it. So we proceed to use it. Here is just simply how it gets used. So, as it says, and if you need to read through it, what this does again, it's all over here. Will you be tested on this? No. This is just kind of this is what a program looks like, especially one that occurs at the end of the semester might look like. This window over here, which first off, if you notice over here, it looks a bit blank. If whenever you see one of these, you can open it up by hitting show code, and we'll be able to look at these. And there's 10 more processes in here, which I will not go over, not directly. There's 10 more in here. Just simply if you want to come back to them and look at how they're done, you can. And in fact, if you hit save and run, it's going to do nothing but define those processes. Okay? Right? So we've got two pictures. So the website will have two pictures loaded up for us to experiment with this. We have we have the bell that we saw earlier, the Luther Bell pic.jpg, JPG. And then my personal preference, which is the yawning squirrel.jpg. Because, you know, it's an animal, and it's a very amusing looking animal at this point. Today's exercise is to experiment, right? We had process 11. Your task today is to experiment with processes 1 through 10 and see what they do. So the bulk of your exercise is right over here on the web page, which is this over here, this matching menu, which says, hey, I'm going to take a process and I'm going to match it with this. And if we look over here, you have a coding box right over here that will enable you to try out what these do. Yes?
Where is it located in the textbook?
They are located, if you go to the textbook, you go to Foundations of Python Programming over here, click on here, you scroll all the way down to the projects list. It is the first project, a preview of the end goal. If you cannot find it via the textbook, you can find it under Module 1 and clicking on the link over here. So over here is a box which loads up the yawning squirrel image, then tosses that image into whatever process you ask for it, and gets the new image. And then it draws that new image. All right? So for example, here is process. Here, this box is currently set to run process 10. Right? There's 10 processes. Here it's going to run process 10. So to do that, I just hit save and run. And it will take this image and it will do something to it. And the squirrel has turned demonic. I fear for my life. So that is process 10. Now, I don't see anything over here that describes it as saying process 10 turns the squirrel into an evil demon squirrel. So obviously we have to figure out which one that is. Okay? But we can do that by maybe going through the other ones and seeing what they do. So so any guesses? And don't overthink this. Any guesses as to how I try process 1 versus process 10? Yes?
You erase the process 10 and change it to the result.
Yep, I just simply erase process 10 and replace it with process 1, which I can simply do by deleting that 0 and then hitting save and run. And then that will run this. If you mess it up, by the way, it will tell you you've got an error very quickly. If it takes a while, you're probably doing it correctly. And we notice that we've got a squirrel over here, and yes, this squirrel does look different than this squirrel over here. So there has been a change. And process 2 over here, right, we can run that very simply. And I'm just going to do this, and we've got a slightly different squirrel. If I try to run a process that doesn't exist, like process 159, I'll be getting an error very quickly. The error is in red over here saying, hey, name error. Name process 159 is not defined on lab 4, right? There's no verb we've created that the programmers created called process 159, right? So we can try our different processes. Now over here there's two pitfalls which are actually the same pitfall over here before you get started. Note that process 5, that all of them are like this. Process 1, in parentheses, IMG. Process 3, parentheses, IMG, close parentheses. Process 4, open parentheses, IMG, close parentheses. Right? Process 5 is different, and process 6 as well. Process 5, IMG, comma, number. In this case, it means that it's going to be expecting 2 arguments to do its job. The verb needs 2 things in order to do its job. Here, process 1 just requires 1 thing to do its job. Process 5 requires 2 things. So go ahead and take a try at this. And if you get stuck there, don't worry, just call me over. And by the way, you feel free to work with the people around you and make plenty of noise. This is one of those things that you're more than welcome to work in a group together. But try to figure out what each of these processes do. Okay? I'll be going around and helping people if they get stuck anywhere. And if you irreparably mess up your code, guess what? You didn't, because you've got a timeline over here that you can always rewind to the base code. All right, with that, I am going to go ahead and pause this recording so that I can, so that when you come back and look at this, this isn't going to be awful. So I'll wait and skip through. So my first kind of loop around the room was to make sure everybody was getting started on this and was on the proper page. Process 5, right, as I mentioned, that and process 6 are a bit trickier. Because if you try to run process 5, you're going to get an error, just like this. Right? 1 missing argument number. What in the world does that mean? As we'll find out, arguments, some of these things require, if you notice over here, process 2 just needs IMG. Process 8 just needs IMG. Process 9 just means IMG. That's why it's got parentheses like this. Basically, it's listing off the things it needs. Process 5 needs IMG and a number. It needs 2 things. So we're going to give it 2 things. We're going to give it an image, which is our original over here, our yawning squirrel, and we're going to give it a number. We're going to give it a small number in this case, like 3. And then we can run it, and then that will work. And so here, it works now. This is the only part about this exercise I find is it requires some extra explanation. Over here, and for process 6, it requires 2 numbers. Again, keep those numbers small. So for process 6, you'd use something like maybe 1 and 2 or something like that for process 6. Right? So, and you can test out and see how that works. So, otherwise, all the rest can be done just simply by changing the number. And as I was saying, the way these in-class exercises work, the way in-class exercises always will work is that I will basically be go over these, and then I'll get to a stopping point, and then I will resume from that stopping point, and I'll give you the solution, right? These in-class exercises are meant to be are meant to be fairly low stakes. You get credit for them. It's about 5% of your grade. So it's meant to be a nice, easy way to create a buffer for your points. So, process 1 over here, let's go ahead and take a look at these. Process 1 does this, as we found out. Process 1, that I believe is the vignette effect, but I'm not sure. Let's go on to process 2. Process 2. says that it will, we may have to use our memory and process of elimination for this. Process 2, we've got this weird effect, and if we look through, I think it possibly may be this Claridon type effect, where the darks got darker and the lights got lighter. But I'll hold on to that for a second. Okay? Not really ready to commit to anything, except for process 3, which I already know what that one is, because I've run it already. It's this. This is what we call grayscale, where all the colors have been turned into, not black and white, but into shades of gray. The way this is done is just by making the red, the green, and the blue equal. If you mix your colors equally, you get gray. So this one I am more than confident in saying, hey, this is grayscale, and this is going to be harder for me to drag as we go on. So part 4, process 4. Process 4 does what? Process 4 rotates it by 90 degrees. Not by multiples of 90 degrees, although technically rotating it by 90 degrees is rotating it by a multiple, but it does one thing specifically. It only rotates it by 90 degrees. Process 5, on the other hand, as you may have discovered, by doing it, let's go ahead and do process 5, comma 3, right? Well, actually, I do 4. Save and run it. Right, it required 2 arguments for us to do. Right, required an image and a number, and I've given it an image and a number. And I didn't save and run it, I guess. Oh, it's smart. It's smart. It figured out that 4. Okay, awesome. I was expecting to see it go sequentially, but I guess it just used some modular arithmetic to make sure that it would actually, not time out. So 1, 2, 3. So what's going on here, right? It flipped 3 times. If I put it in 2, it's going to flip 2 times. It's going to flip. We get our picture, then it flips 90 degrees. Then it's going to flip 90 degrees, so that's does a full 180. So it's now hanging upside down, and now that squirrel is very surprised. So, yeah. And now, this is what I mean by it's getting hard to use, so I'm going to just need to zoom out, drag it, drop it in. Now, this one requires, process 6, it says it requires an image, 1 and 2. We'll learn more about how to make sure this works. It's okay if you're like, I don't understand what the difference is and why I have to do it for this. That's fine. It's not needed for this one. It's kind of exposing to the idea and kind of the syntax, the way it looks. So process 6 requires 2. And the only reason I know it requires 2 is because, if I try to run it requires 3. So if I try to run it without 3 arguments, it will give me an error. And also because this part of the puzzle says it requires 3. Original. And then I'll do 1 and 2 over here. So here, and then it got nice and big. Honestly, I think I'm going to do and then just to test it out here, I'm going to do 2 and 1. And we're going to make our squirrel become a nice and chunky squirrel over here. Because the 2 and 1, what it is that it's saying, if we look over here, we've got something that describes it, which enlarges it in the X and Y direction. Right? Number 1 and number 2. The first argument says, hey, how much is it going to stretch it into the X direction? And then the second number is Y direction. Okay. Now process 7. Process 7, and all the others just simply require 1 argument. Process 7. Argument, parameter, yeah. There's typically a different one. Ooh. All right, what do we have here? Well, this looks fully black and white. Converts image to high contrast, black and white only. That seems to be our key. 7, black and white only. 8. It's a useful tool. If you hold Control or Command and then use the mouse wheel, that does do zooming. And if you need to get to reset your scale, there's always a way to do that in the hamburger menu. Now that lightened it, definitely. 7. Wait, no, we've done 7, so 8 is lightened. 9, that's almost certainly going to be darkened because I'm just checking the time. Plenty of time. Nice and early, to be honest. There we go. There's our darkening effect. That got darkened. And then, if we remember, we have Hellspawn Squirrel as numbered 10, I believe. Yep. So, and now because of process of elimination, we've got a bit of an easier time figuring out what process 10 really is doing. Okay. So we run process 10, and we get our squirrel over here. And converts only to black, white, red, green, or blue. And we've got, and it's hard to see, it may be a bit hard to see up there, but we've got a green pixel in the middle, sorry, a blue pixel in the middle of the eye, a green pixel over here. And a bit of green over here as well. That's a bit easier to see because it's a cluster. It's probably basing it off of how intense each color is and whether or not one is more intense than the other ones. So we are going to drop this. So converts image to only black, white, red, green, and blue. And so that leaves by those original 2 that I wasn't really willing to commit to. 1, right, which is going to be the vignette effect because it darkens the corners. And then part 2, which is going to run this, and we get our Claridon effect, which the darker's dark, the lighter's light. And then I'm going to hit check me, which I've never seen this before. I don't know why it's giving me this error, but it is. Honestly, it worked, though, so I don't care. I've never seen that error before. Like I said, free textbook. Sometimes it has quirks. Okay. And then we have our last batch for the day. So each of those processes are a verb, and you can, chain verbs together. You can do one thing, then you can do another thing. You can use each of these functions, right? Now, a lot of times later on in the semester, we might see something that's complicated looking like this. Process 1, open parentheses, process 4, open parentheses, my image, close parentheses, close parentheses. One of the things that Python really gets right as a programming language in its philosophy is that code needs to be readable. I find this to not be that readable when you embed things like this. So for most of the semester, I'll be doing a lot of things maybe a little less efficiently, a little less, and a little more expressively than I could potentially do. But that's because I value readability, especially at this stage. Because I might write this code once, but it's literally going to be read 100 times. It's going to be read more than I write it. Even if you're just writing it for yourself, you're probably going to read it more times than you actually spend writing it. But here, literally, I've got more eyes than my own, so I need to make sure it's easy to read. So over here, what we're seeing, so this thing can be expanded into multiple lines. In fact, that's kind of what's going on over here, only in reverse. So here it's saying do process 4, then do process 1. Over here, though, here is some text for combining these effects. What we can do is we can say, hey, let's take our image. I'm going to do process 1 on that image. I'm going to take our original image, do process 1 on it. And I'm going to store that in step 1. Then I'm going to I'm going to take our intermediate image, our step 1, and run process 4 on it. So process 1 was the vignette effect, and process 4 was rotate 90 degrees. Right? I can also do something like, there's nothing stopping me from doing, hey, let's go to process 10, from process 1 to process 10. Instead, right? Process 1, process 10, right? And we got rid of that little cluster on the over there. Yes.
What happens if we do all 10 processes?
It would take a while. That's what would happen. And also it probably look like a mess, right? But if you wanted to combine more than one, but that leads me to another good question. You do another good question. What if you wanted to do more than one or do the same one multiple times, right? The flow of this program works is that we create more and more steps before our final step. So I might put in a step over here, like let's say step 3 is our last step, or sorry, step 4 is our last step, like it used to be. So might do maybe step 1, then I might have a step 2 is equal to, right? And it makes sense that I would put a step 1 after step 2. It doesn't have to be that, right? I could call it whatever I want. As you'll learn, you can call it essentially whatever you want, like Bob. But and then you could do something like this. But step 2 makes more sense, right? Readability, process 10 takes the image that is, so we do process 1, right? Get the original image, run process 1, and store it in step 1. Then we do process 10, and that takes in step 1, and we store it in step 2. And then we would want to change what's over here in this line, because right now again, computer's an evil genie. Right now, we then tell it to use step 1 again and create an image and store it in final. And what we need to do is just make sure that it's hooked up correctly, right? Here we're feeding step 1. We're saying make an image and then use step 1 to do both of these. That's not what we want. We wanted to say here's step 1. Use step 1 to create step 2. Use step 2 to create the finals part, right? Makes sense? So everybody kind of see how it's kind of like chained like that. It's not that it wouldn't work, it just wouldn't give you the desired result. That's the worst kind of error you can make, because it's working because it's not crashing. And then we can, go further on this. And like I said, you can call this whatever you want. Again, I could call this Bob, but calling it Bob doesn't really add to the readability of it. It doesn't make it easier to read. We'll learn more about the variables and what we can call them next week. But a lot of our classes will be essentially working on projects from this textbook in class, doing them for credit. Now, how do you make sure you get credit? A lot of time in all these ones, it depends on what we're doing, on which parts of the page I go over. Like some of these projects are too big to do in one lecture, and I just do a subsection of it. But there's always a questionnaire at these, and you want to fill those out and say, like, I was in my comfort zone, because of course I'm in my comfort zone. This is my happy place. I'm teaching the class. So, but it will keep track of all those activities. Now, if you fill this out, you might see that you only have 9 out of 10. If you only have 9 out of 10, just scroll all the way back up until you get to over here, where you'll see a save and run and then a show code. You won't have the share code. I only have the share code because I'm the teacher, which allows me to share the code with any code that I write with you. This is really useful, right, when I later on in the semester when I write some complicated stuff, and rather than you having to take a picture with your phone or me send it out somewhere else, I can just hit this button and share the code with you. But what you'll need to do is that to get that last 10 out of 10, you just have to hit show code and hit the run button. And then it will register that you've interacted with all the elements in the page. The purpose of this is also to show you that later on in the semester there will be some code boxes that, for some questions, that you'll just have to hit show code to see the question. But yeah, this is the way that things will work throughout the semester. On next Tuesday, we're going to do more of this kind of stuff. Only we're going to use we're going to go over what we'll be doing in what's called Lab 3, which is our turtle. Then in the next lab, we will be doing we'll be doing Project 2 on Tuesday, Project 3 on Thursday. And those will be kind of just very basic kind of understanding how statements work in programming. How to say, I'm going to do A, then do B, and so on and so forth. Lab 2 are our first actual programming assignments. Your first one, and if you haven't had lab yet, is just simply printing out facts about a famous computer scientist. Or, as some of you have asked for, people who are very adjacent to the computer science field. I'm very flexible on that one, as long as they're interesting. So, with that, I think we can let out early, plenty early, so that if you have any questions, you can come and see me. Because this is the point, and if you have questions or if you're difficulties, you should let me know. Otherwise, I will see you all on Tuesday. I hope you have stay warm because it is going to get very, very cold next week. Very cold.